Hi folks, it's Welly speaking again. Welcome to video number 6. In this video 6 and 7, we will be demonstrating what if the primary region is down. Video 6 will focus on the solution design and the setup, and then video number 7, we will show you the actual running demo. Before showing you the solution design, I want to spend a bit of time and revisit the original architecture, identify the potential challenges, and see how we could improve that. By looking at the documentation, it described that you can define automatic failover policy in Azure SQL failover group. However, you see that only one hour it's the shortest setting that you can define. And many customer might feel the needs of shorter recovery time because otherwise when the downtime happens in the primary region, you will need to take at least 1 hour in order to fail over. And I don't think everybody will be able to accept the recovery time of 1 hour. Now, after checking the SQL documentation further, we conclude that at this moment, there's no way to set to the shorter time frame. And this is because the mitigation involved human actions by the operation team. The objective is to try and get the primary server back to normal as soon as possible. Unless after multiple attempts, the primary server still can't be revived, it then will fail over to the secondary. I understand the rationale of these decisions. A database failover is rather a big exercise, and that needs to be done in a very careful way to avoid failing over back and forth multiple times. Now, nonetheless, you still can design your DR workflow to achieve shorter recovery time. This is in fact what we will be doing in this demo. Our objective is to streamline the traffic manager and the database failover as close as possible. So what we're trying to do is to raise an event failover of a failover database event through the API when the traffic manager is failing over the web endpoint. As such, we can leverage diagnostic log from Traffic Manager, which periodically emits the health of each register endpoint. So we can connect the diagnostic log to the Event Hub for real-time ingestions and make use of Stream Analytic to query the status of the primary endpoints. When we detect the down status of the primary endpoint, we will then invoke Azure functions to perform necessary action. We have two options here, which can be easily triggered just with a setting by defining a value of full automated failover to 1 or 0 in our Azure function. If you choose to fully automated failover, it will immediately invoke the database failover. However, if you choose to involve human intervention, as such, an email will be sent to the admin and giving the database failover decisions to the admin. Now let me show you how this is being set up. I'm going to move to my Azure portal and start by showing you the traffic manager. As you can see that I have web two web endpoint both enabled and both online. What I can click is the diagnostic setting, and you can see I have successfully associated my diagnostic setting into my event hub. I'm going to click edit setting, and you will find that both log and metric, I decide to stream this to the event hub by defining the event hub which I have pre-created. Okay, and then what it does is if I move to my event hub, you can see that here are number of request message and throughput that was fit by Azure Traffic Manager over a period of time. Okay. Um, I will be also showing you a raw JSON file, how that looks like. So look at this example. These are a list of endpoint along with the status emits from the traffic manager profile indicating the online status of the endpoint. Look at this properly, and this is where exactly what we are interested most. We want to know when the endpoint is down, so that the moment we detect this, we are going to make use of Stream Analytic. Um, and moving on to Stream Analytic, you can verify that the input has been set to the event hub. This is the event hub name. I can perform query by checking the status of my endpoint, which is down, and that is what I'm most interested in, and then subsequently perform an output. Now, if you look at the output here, I have multiple output options, and I decide to put an Azure function to invoke a specific function. But then if you can definitely add other output as well, such as store the data to SQL database, table storage, Cosmos, and so on. I'm going to show you my Azure function as part of this flow. So my Azure function has been also deployed here. Let me switch to my Visual Studio and show you how the function code looks like. So first of all, basically, we're trying to get the setting from the app setting.json file. And the more important thing is we are checking the failover action type. If the fully automatic failover was set to 1, we will be triggering the failover. And the failing over here is essentially invoking another method, which essentially call a database failover of the SQL. Okay. The second option is when you set non-fully automated, it will then trigger a logic app to send an email. So this is the code that triggering a logic app. As you can see that we put the logic app URL into a config file. Okay. I'm going to show you the logic app then. Here's my logic app designer. As you can see that my logic app, and this one is actually deployed in EastUS. This is how my designer look like, logic app designer look like. It will have an endpoint of HTTP, HTTP trigger, and then I basically create a variable to construct how my email look like, and tells you that, hey, the traffic manager detected the front end failure. As such, we are failing over to the secondary web endpoint. Do you also want to initiate the database failover, right? And then this will be sent to my email and my colleague Adit's email. So this is how the workflow looks like. And I hope that makes sense to you. In the next video, we will be showing you the working example of end-to-end, how it runs. It got failover. So thanks a lot for watching this video. See you in the next one.